So the structure, overall structure, is at the top of the heap. The final product is the project, and it might be a kitchen cabinet. It might be a collection of kitchen cabinets. It could be anything. I've heard tale of somebody that actually designed a house in SketchList, but I hadn't seen it yet, so we'll hold back on house building. But it really wasn't intended for that. I mean, it was kind of furniture making, cabinet making, fine carpentry kind of. Inside of the project, you can have one or more assemblies. How many assemblies? It's a matter of logic. How would you build it? If you're going to go into a kitchen and you're going to put up one wall of cabinets and you're going to hang them and build them right on the spot, well, then I guess you would have one assembly. But if you were going to build the cabinets in your shop and have to get them in your truck and up the stairs and so forth, you'd probably just have as many assemblies as you have cabinets. Inside the assembly is doors and drawers, and I'll get into those later. The reason we have assemblies is because we want to be able to manage all of the parts. And if parts were just sort of falling around everywhere and they weren't grouped together in some logical fashion, it would be harder to do this. I mean, I've heard from a fair number of users, SketchList users, that really only ever use one assembly and they figure everything out on their own, and they're happy. So if they're happy, I'm happy. So this is a way to manage a group of objects. So make it a little more clear, I think. The first thing it does is it lets you save and retrieve cabinets or carcasses or doors or drawers, anything you want. You can save them to the library for use. And say, for example, I just take this. All I do is click the add button, and there's the cabinet. Now, the overall thinking in SketchList is, if you were doing a lot of cabinets, you're doing production, you're doing a big house, and you had to do all the cabinetry. And the overall idea is you would build like a seed corn. You would make one cabinet and make it precisely the way that you build. So if you use the Craig screws, pocket screws, you can use those. If it's mortise and tenon, you can put that there. The point is that you want to create, in every step, you want to create your design to correspond exactly to the way you work. Or it may not be exact, but you'll know. You'll say, well, this job I'm doing something a little. I'm not doing any face frames or something like that. But you could still start with on objects in the library, and that's a big savings in time. It's like I guess it's like anything else. The more time you put more time in the beginning creating your standards in your library than you will later on when you're just going in and touching stuff up. You might change a contour type or something like that to make that rendition of the drawing fit your specification for a particular job. So what can we do with the collection of objects? First of all, we can resize it, which is a pretty important thing. I'm going to move this all the way to the bottom of and this is just a slider bar. It moves things up and down. Just what I picked to do. Now, this is a 12-inch cube, and if I had a requirement for, say, a 36-inch cabinet, there's 3 ways to change things. I can come up here, which, in my opinion, if you want to resize something and resize the contents, this is probably the best option. So I'm going to right-click that with my mouse and say this is 36 inches. Oops. 36 inches. And there it is. And if I had put in, say, a stack of drawers and a door, I could just then take those and make copies of them and fill out, and I would be done with this cabinet. And I can change this size in any direction. So this is, say, 36. that. And that's how to use that tool. If I wanted to, say, move it to the left, I can click on the blue dot. Blue dots locate, and I just say I want that to be a left of 0 and a front of 0. Now in front of 1. Say. So the dots, the blue dots will move things. The calculator works just really the same way, except in a different format. These 9 text boxes and their buttons can size or locate anything in 3 dimensions. If I want to make this, say, a bit wider, it's 30 inches wide. What I can say is I meant to say 34 inches wide. And when I do that and click off of that 34 that I entered, I have 2 of these buttons have turned green, which means they're hot or they're going to be active. I can't go to the left anymore because one of the rules in SketchList is everything must fit in its container. So this is a calculator in as much as if I said now the left is going to be 6, I want to keep the width at 34 and I want to move it to the right. I move that and that's that. Now that's pretty simple. You should never have to think about the sizes other than if you have them set, you want a definite size, but then calculating and then setting the location, but calculating the final result, you don't have to do on a pad and pencil or on your phone. This is a calculator. In fact, it works such that I could say, I want to take, say that. I just pause my cursor in there for a while. Now I'm going to subtract 2 inches from it. And I want to move that to the left from the right, like that. Now what you see here is you see the cabinet, the green box, that's more cabinet space. And it's empty right now, but we'll put more in there. And then the wood is, of course, the wood. The reason that green box is out there is because I changed something here when I made that 4. It moved it over 4, but the green box really didn't change. I'm just going to Control Z out of that. There. All right. So that's the calculator, and I could do that again. I could any size. Now that's 1. I could make it a 1/2 inch to the back. It moves up like that. Now the spreadsheet works the same way in as much as if I'm going to change something, like I want to change this to 33, and I come off of that in the spreadsheet, these light up as green. That means that these are the things that I can change about this piece. I wouldn't change the width because that's the thickness of the plywood, so I'd only really change the left. At 33, this should become 3, and it did. The obvious distinction is that between the calculator and the spreadsheet is that the calculator works one at a time. And I don't use it so much, I guess I use it to change things, but I really use it as a reference point, like a gauge. If I want to know, if I come into that assembly, and I can get into that assembly by clicking up here, or I can click on any of the boards within the assembly on Add Slider. Here's the board. Now I want to know what the top of the board is. It's 35 1/4. Is that the same? It's 36. Well, that's because of this should be 3/4 of an inch tall, which it is. And that's kind of the way I use it. Then if I said, I want to have that to be shorter, let's say 24, 2 green lights, I change the height and it changes that way. And I think this was 36. Right. Now with the spreadsheet, the reason I put this in, first of all, so what I want here is I want the ability to look, and like before I was wondering what the tops of all those boards are. Well, it's 36 inches. Okay. I don't have to move the cursor there. I don't have to move the cursor there or click anything. I can not even click the cursor here. Just say, all right, the top of this board is 36. And I could change that 24, click off. My options are this or that. See how I do bottom. I don't think this is going to work. Yeah. Now what happened was, if you add 36 and the 12, which comes up as negative, that caused this board to go outside of the assembly. So just undo it and do it again. So here I could say the height of this is 12 from there. But it's a matter of just playing with it. If you want to sort this, you can come in you want to select these. Say, that's another reason I should really be naming the boards as I go along. But I can go in here and say, I only want to deal with those. So those are the two boards. So it's a filter, actually. I come here and I right click and I select all, apply. All of them come back.
But they didn't hide, did they, Dave? You just took them off the spreadsheet with that little.
I don't know how that's accomplished. I expect it's a hide.
Well, but they didn't hide from the view, so you can still see them even though they're not listed on the list.
Right. Okay. Yeah. I thought we were talking about this.
Right. Yeah. No. The hidden part I use all the time because that allows me to see the shelves on the inside and the drawers and all that stuff. But
right. So really that selection thing is if you have a lot of boards and you don't want to scroll down up and down all the time, you can do that. You can take this and make it bigger so it's more scrollable. And I didn't talk about the screen, but all of these screen segments are movable. I could take this and put it off on my laptop, which I'm using to drive this meeting. I can hide things. In other words, I could make this bigger without making this bigger because I could lose some more space and configure around it. And to get back, you just grab whatever, say I move this over here, like that. I want to get back, I just take it and put it back, like that. The other thing that I'm doing here is if I come to the column heading and do a shift mouse click, it's sorting that list of item names. And one is sorting ABC and the other sorting the ZXY or whatever that end of the alphabet says. And you can actually do that up here too. Okay, so you see it's sorted by order of size or distance from the left. Distance from the left. If I wanted to sort here, so I have 36 on the bottom. This 36, it refers to the assembly, not the objects in the assembly. We're still talking about assemblies, and assembly being the container that allows you to manage your project.
I've said this in the past, Dave, and I'm going to say it again because it is so important. If you are going to start a project where you're building something that is going to have similar characteristics like cabinets or even two end tables or something that's going to be the same, I beg you to make sure that what you're doing, that you do the effort and put the effort into the first one to figure it out and clone those things, but figure them out first, like the grain of your board, figure out what that is, do those calculations and put that in so that when you clone it, they are cloned across the board and you don't have to go back through and touch every single one of those pieces. because you just missed that one piece or whatever it is. And it can be the material that you choose or those kind of things. The work that you put into that first one, or the work that you put into that first drawer or that first door or whatever you're making, just goes so far, so far. I have killed more brain cells by having to go back through and redo those things.
Couldn't have said that better. It's like I'll be talking to somebody on the phone and something's wrong and we're doing a screen share. I saw there's something wrong with the board. Let's delete it and recreate it. Oh no. So why not? Well, we should just fix it. So it's going to take 2 minutes
More
to
time
fix
to fix it. Yep.
and 4 seconds to redo. It's like, I guess men just don't like to admit they're lost. They won't go back to the starting point.
So that back panel, let's just take that back panel on your cabinet you have there, right? So typically I will put in a 1/4-inch dado on each one of those boards on the back. If I'm using a 1/4-inch Luan or 1/4-inch board on the back side panel, and I'll put a 1/4-inch dado 1/4 inch from the edge, and I'll put it a 1/4 inch deep. And so you want to make sure that if you are using Optimizer to cut that board, and so you have the right dimensions, that you make sure that the board is inset to those other boards a 1/4 inch. Now, also to save time, that doesn't mean that you actually have to go in and put the dado on every one of those 4 boards either. All you have to do is set the board thick, wide enough to make sure that you have the board the right dimension for that. So sometimes, I mean, I look at it this way. I could spend probably 5, 6 more days on a cabinet by putting in all of the contours, all the dados and everything that I know are already going to be there. But because I have a standard or I have a way that I build a cabinet and I set them all up that way, and I've cloned them all that way, because I might use that cabinet and clone it for a completely different cabinet, but because the back is already set, all the depths are already there, I can stretch, and like Dave showed on how that into the right size that I want, because all the rest of the pieces are set exactly the right way that I need them. And all I'm doing is stretching the middles where I need them to be. I don't know if that helps anybody or not, but it if somebody would have told me that when I started this thing.
It's like I do that at these class things. Like, now I've made this without detailing anything. But say I wanted 2 rows of pinholes for my shelving. Well, now I've got to go in and do it here and do it there. I mean, there's a copy command that'll do that easily enough, but you're just really better. So what I think I'd say is that you could take, you could take this out of the library and just box out a design for yourself without thinking about any of the details. Just do the proportions look correct? I mean, you know all of this, and then just say, well, all right, now just go and make one of those cabinets in SketchList and make it so you could just take it to the shop and make it just like the plan says. And if you're not right, then the plan's wrong, or you made a mistake. Yeah. But I'm sure no one here makes mistakes.
That is what I was going to say, Dave. The work that you put in up front, because I don't want to have to second guess when I get down to the shop that I actually did I stretch that to the 1/4 inch over, or is that if I cut that one 42-inch wide by 75-inch tall piece of Luan that I'm putting on the back, or that piece of 1/4 inch on the back, and I'm going to cut it, and it wasn't sized correctly, so therefore I just stretched it to the edge like Dave shows in all these sessions, because all he does is do the shift key and he stretches to the edge, but he didn't stretch it the extra 1/4 inch to make it the right size. And so I always got to think about, okay, let me go in and check where's the left side of that, or I go into the shop drawing, and then you can actually see that they're laid out, and click on the left work level to see does it overlap the 3/4 inch on the outside. And so that saves so much time in having to think about it, because it can be stressful when you're in the shop thinking, oh, did I cut that but then you cut this one board that you just spent 85 bucks on, right? Because this stuff ain't cheap anymore. I mean, maybe before COVID, you could probably, okay, I'll use it for something else. But now they're just too expensive to be messing around.
Yeah, that brings up another point, and it's talking about two different ways of doing things. Now, Ed is saying that he goes in and he essentially adds, on the left side, he subtracts a quarter of an inch. On the right side, he adds a quarter of an inch, adds on the top, and nothing on the bottom.
No, I add all the way around. I put a dado all the way around.
So he does that, and what that does is that makes the board makes its cut size bigger, and a lot of people do that, and I understand it's just quicker really to do it this way.
Oh,
I think, but then you're carrying the burden of understanding the difference between the cut size and the design size. The cut list will always give you the cut size, but I get confused. I used to get confused about that sometimes. And more than once have I cut a board shelf that was just a quarter of an inch too short. And I went into the scrap pile for something else. That's when things were cheap.
So what can you show?
Yeah,
show me,
I'll do that now.
What am I doing that I don't have to do then?
So let's go to the board detail level. Now, all right, I hadn't talked about boards yet, but we'll kind of back into boards. This is a board. It's a three-dimensional object.
Yep.
And I'm going to go to board details. Now what I can do is if I highlight the edge, which turns out green, hold down the shift key, highlight the edge, and go for all four of them.
Yeah.
And then I could just say joinery and say rabbit. These are default values. You can change them, and that's fine. But here's the map. Z is how deep that is. So in this case, it'd be a quarter of an inch, like that. And then the number one value, what would that be? That'd be a quarter of an inch, like that.
But I'm not putting a rabbit on that. I'm putting a rabbit in the, is that?
You're putting it on shelves?
I'm putting it on the outside.
On the sideboards. Well.
In the sideboards, yeah. So you want to put a tenon on this, right? Is what you're thinking?
Well, you could. Yeah, you could. I thought that somehow you cut out the back.
No, I put a quarter-inch dado in the quarter-inch from the back of every one of those boards, and that's what I slide that quarter-inch in for a back of a cabinet.
I got you. All right.
I don't know if anybody else does that, but that's how I build cabinets.
So I'm just going to accept all of the defaults, and there you see them.
Okay.
Right? And just about make that one out.
Okay.
I succeeded in keeping my record of that gives you your tenant. Okay. Best look, I think, is that just right there. And you can have them facing with those adjustments. See, now it's all centered. But if you wanted to, you could change the size of that. You can make it thicker. You can make it all the way across, and like that.
And that's on a 3/4 inch board on your back. Well, I use a 1/4 inch on the back, so I don't have to cut the board at all.
Right.
But so my question then is, what does this do to the size of the board?
Great question. So we maintain two different dimensions for the board. We store the design dimension, which is in this case the distance between the styles.
Yep.
And we save the cut distance. So, and some people don't agree with me on this, but so the outside to the outside, if this is 28.5 inches, so if this is a 1/4 inch and the one on the other side is the quarter of an inch, that would be 29 inches is the cut, and 28.5 would be the design.
So the purple box is 28 across, 28.5 across, and adding the tenons on, you're going to get to 29.
Right.
So where do I see the 29?
in the reports, the two places you would see it is on the cut list, which is the hobby version of this.
Yep.
On the cut list, and you'll see it's labeled cut thickness, cut width, and cut length, right?
Okay.
So, I see. So it's 28.5, I think, and it should have been 29, but I didn't actually put a tenon on both sides. So that's the first place you would see it. And for the pro users, you do the parts list, and you'd say, do part name, part width, part, and then a cut. So you'll see on your report, you'll see both the nominal or the design size, and you'll see the cut size. Does it matter? Some people it matters very much to. They do this and they might have like a half tenon on there or whatever. To be honest, all I do is I pay attention to the cut width and the height, because I want to make sure that that's the cut size and not the design size. And then that's as far as I go, because I know that a lot of the times I went up to my router table, it was set to cut this. So I didn't have to bother drawing it out. I saw no real purpose to that. And I just ran it through the router. That same logic goes for everything. One of the interesting designs somebody sent in one time, it was a proposal he made, and I looked at it. It looked really nice, and I took the kitchen and I rotated it, and that's exactly how thick the kitchen was. All he did was do all the boards I'd show, and he didn't bother building out the drawers or anything. And I said, well, what are you going to do? He said, why would I waste any time at all if I'm not getting paid for it? Good point. So I think, however, that when he makes his first project, he's going to wish that he had created a standard, because after you make your very first box, that just becomes just as fast as putting in a blank, a no back, what do they call it, facade kind of thing. So I've been talking about boards for a while, but let me, it's very important to understand this, because it's everything most of the things we make is out of boards. So it needs several pieces of information: shelf, and where is it going to go into? It's going to go into this assembly. There's only one. I don't want to use a kitchen sink. I don't want to use metric. I don't want to use solid lumber. So I'm going to pick, and I can change these. I can come up here and say, I want, I pick any design that I like. Right? I'll stick with what I have. So there's two pieces of information. What material is going to be cut from? And you have to pay attention to the size of the material, because you can't cut a piece bigger than the material it's getting cut from. And Ed had mentioned before about the grain direction. Sometimes people will say, well, that really should fit. It's 60 inches and my board is 96 inches. Yeah, if the grain direction's laying the same way for both the 96 and your 60 inches, that's true. But if you've got the grain direction off 90 degrees, it's not going to fit on a 48-inch piece. So I'm not sure people, pay attention to this, but you should. And when you come here and it says, you'll get a message saying that board's too thick for the material you picked, and you'll say, I got it. Okay. So here I'm just going to make, and I don't spend a lot of time here. This is important. And that's important because it's a thickness. And it gets back to the idea of laying out the cut list, parts list, and the optimized diagram. We want to, that's how we define a board. Which of the three dimensions is its thickness? Does that thickness match the thickness of the material? Okay. And a lot of times it doesn't. Not a lot of times, but occasionally it doesn't. Somebody start using 1/2-inch parts and 3/4-inch materials, which isn't always an error, so we just issue a warning on that. So I'm going to say this is 12 as well. And the other piece of information, as we've been talking about, is the grain direction. Now, I'm not going to fool locating the board. You do three things when you design in SketchList. You insert something, which we're doing here. You size it, which we've done there in part, and you locate it. We'll do that using the other tools. So I'm going to add this board. And there it is. So I come back to the assembly level. Now what's happened is my shelf is down here, down there, and I can go and, well, I can go and just say the top of that shelf is going to be 24 inches. I'm going to keep the thickness the same because it's the material in the bottom, like that. Now, as Ed said, in this regard, I'm a big drag and drop guy. I hate to drag and drop, but because I've got that click here, and that I just don't like to get, when you drag and drop, you get 12 and 97/100th inch. I'd rather either drag and to a board, or I'd use the calculator or the spreadsheet. Now what I'm going to do, and here, looking, and I didn't name things, looking there at the front value of that right here is 11.5. So what I want to do is just check and make sure the back value is 11.5, which it's not. So this is 11.5. And that's what I was talking about earlier when I said I use this like a gauge. It just helps me decide. So I'm going to leave it at a zero of front of zero. So I'm going to change the depth of that cut on that board. And that's a board. And in our, whatever looks like a bookcase, we've got three types of boards. And the thing that distinguishes this board from this board to this board are really its grain direction and its thickness. Here, the thickness is front to back, so you're 1/4 inch from front to back. Here, the thickness is horizontal, because that's what it looks like. And here, the thickness is height, whatever height, vertical, I guess, is height. And that's why, that's part of most, well, that's most of the reason that we ask you to enter grain direction and thickness. And the others, for sure, the optimizer and such, also depend on it. All right, so boards. And then I come back to the project level. Now I'm going to just take this. I'm going to edit the project. I'm going to make it real wide. So I just went in and edited the size of the project, so I can make a copy of this. So there are three different kinds of copies. And this is, we're talking about, imagine that we either built this, and now the thing to do would be to say, add it to the library and save it. So after that closes, we'll have access to this box BVV for other use in this project or in other projects. And what I might do is, if I put a drawer in there, I might save it to the library again. If I put 2 doors in there, I might save that version to the library and name them appropriately. And then you're well ahead of the game of of the design thing. So first thing I did was I made a copy in the library. To pull it out of the library, all I do is go as if I was inserting a new assembly, but this time it's from the library. Usually it starts out life on the bottom, that's like we all do. There. And its location is, it's just the center of the project. It's the safest place for us to put it. You might have saved a big assembly and then try to put it into a small project, and you're going to get the message that that assembly won't fit in the project. So that's one of the rules. Everything has to fit inside its container, always. So here we go. I want to, talk about moving things as a group. If I come down here, the blue dots are the things that locate in the design approach. So here, that blue dot is 33 inches from the right 0 from the bottom. It's sitting on the floor. It's a 1/2 inch from the front. So I'm going to copy that information. I come up here, take that corresponding blue dot and paste that other information, apply, and now I've got that. And I can take this and change its size. So its height is 48, let's say. And there it is. And you'll see in this case, it actually moved that shelf.
Because your halfway line was below it.
That's right. Yeah, let me undo that. That's a good point. So the question is, how do I make that size change and not disturb this board? So I do the same thing. I do this here, and you see the box, and just take that side, take this side and bring it up. Now when I make it 48, and the reason is that when you're resizing, the rule is that anything that's completely to this side of it stays. Don't touch it. If something is cut by the slice plane, then we're going to add, in this case, I think it was 12 inches, add 12 inches to the height. The first time I did it, the slice was below the shelf and it got pushed up by the 12 inches, which we didn't want. So I redid it, no big deal, and that's that. So now those are the same height, like that. Another way to manipulate an assembly is I can clone and mirror it. In this case, they're both symmetrical. There's nothing different. But if this design was asymmetrical, and say you had a door on the outside, it would have gotten flipped so the door is on the outside here, facing the correct direction. And do there, I'm going to go into my little area here, say this left value of that cabinet is 67. So I'm going to take this and say, this is 67. And now everything matches up.
Beautiful.
And that's kind of getting to, if this was completely decked out and had the drawers and everything in there, everything gets changed. And you have to think a little bit about where you're putting the cutting plate. We talked about the board detail earlier with the clone, and I'm not sure, did I do holes? So if I go to the board detail level, I'll do these two things anyway. Go to the board detail level, say I want to add holes. Now what we do is we say we want a round hole, and it's going to be 6 inches off the bottom, 6 inches from here. Diameter is going to be 2 inches, and the depth will be 3/4 inch, like that. And that's it. You can make them round, square, rectangular, or oval, and you make them any size. It has to fit within the board. If you make it such that it's just even coincidental with touching of the edge of the boards, it's illegal and it won't be allowed. And then you can edit those if I wanted to. I just pushed edit holes right there. Came up here and said, all right, I want to clone and space that hole. And from the bottom, make space is going to be 3 inches. Now, that diameter make for a pretty loose fit around a pin, but you get the idea. You would do the same thing.
Pretty big shelf pins.
Pretty big shelf. You would put a piece of rebar under there to slide. Forget about the joinery. We got a new way to do this.
You said you wanted a chunky,
industrial design.
Yeah. You wanted chunky, so.
So now what that makes it is it's not a bookshelf for your house. It's a backdrop for a bar where they could put a nice piece of glass on there over the rebar and chrome stuff. And anyway, all right. So that's boards. On boards, you can create a new material. The reason that's interesting is, well, you can make it any size you want. you can make a brand new one. So if I'm going to add a brand new one, and there is a thing to know about here, so I'm going to add a new board. The material name is Thursday. Call it sheet goods, and then I'll put in the sizes, 48, 6. And if you use bigger stuff, you can put bigger in. So I'm going to say the grain direction is going to run the length, and I can pick any grain I want. Say they say this is going to be granite, some kind of stone or a wall, or whatever. It'd even be a television, an appliance for a kitchen, that sort of thing. And how do you do that? You say, well, you can add your own textures. Oh, it's asking me where the graphics file is. I'm just going to use that. Is it transparent? Fully transparent? Of course, fully transparent, it just disappears. But it will when you're doing your photo finish kind of imagery. It'll show a shine on it. So it does have some value. You say, okay, just about ready. Shop drawings. So we're going to go to here. Tools, shop drawing. We're going to make a new one. Now, shop drawings, you can position from anywhere. Front, back, top. It's a two-dimensional drawing. Go back to the front. It's a two-dimensional line drawing. And there are really just two tools for doing the dimensions. So in this case, we're at the project level. So the only thing we can do right now is either change the level or dimension out the project. So I clicked that cube-looking icon, which says size. And then I said, all right, well, that's 36, and this is not 36. It's 39. Because in the end, I moved it, remember? And that's 36. So now you've got an elevation, essentially. You can save it or print it, and you'll be all set. If I want to go into one of these assemblies, what I can do is I can come to the work level ladder and say that I want to know the definition or the size of that shelf. So I just will shift it. Thank you, Ed. Now I can take my tool again and say, okay, that's whatever, 32 and a half. And I could go in here and think, oh no, point to point. I can put these dimensions between the holes on centers here, or I can you can grab essentially any corner, and I can grab that. I can take, let me just grab one, go to the outside here, and then when I try to do that diagonal, if that's not what I wanted, I can just grab the pointer and move it around. And you can do any three. So I guess technically we didn't even have to do the line tool. We could have just gotten by with the point tools. Well, I guess line is a little faster. And then the final part of this, so I want to run an optimized layout. And
look at that.
Look at that. So this has come up clean, and it was greatly helped by the idea I started with the library objects, because I knew they were good going in. See, a little bit different. Remember I said the thickness 3/4 or a half or whatever? What this material here is 3/4 of an inch, and so is this, and so is that. So what I have to do is I can fix that. I can either go in, I click this question mark, go to part and design, and I can take that is a 1/4 inch, because that was that back, right? 1/4 inch. No, thickness is a half. I could change this to a half, to 3/4. That was just a warning that said you've got some joinery on there. It might distort. Make sure you check it. So I made that the right size, and I'm going to call this the backboard. Now, if I run the optimizer again, the issue went away, and I'd still have to go into, oh, yeah, those were the two boards, but the backboard isn't there, which means the backboard passes. Now what I can do is say, kind of in a hurry, I want to run the optimizer anyway. I'm not interested in cutting anything but 3/4 inch material. And, you know, whatever your plan is. And again, those are all too thin for the size. So all I want to do is cut the shelves tonight. Then I can come down and say, on top of that, I could specify which assembly I want to optimize. So I might say that box VVV was I think that was the center one. It was taller. Maybe I don't want to work on it this weekend or whatever. But all I have to do is click optimize at that point for the material. Now you can, of course, change the kerf on the saw. If you were running a CNC machine, you might want to put in a different size cutter in that and do that. And show the cut locations so you know where your cuts come out. And this is a guillotine approach to optimizing, which means that you always get complete cuts. Or I should say, if you think about it, you can always get complete cuts. My first cut would happen here. Maybe I'd trim up there first, take another cut, then cut. Well, you can do it better than I can.
Dave, your blade width starts at 1/8. I was wondering if we could actually have that down to even a 32nd. I've got bandsaw blades that are 1/16 or less. Can you slide that over? Did you get those guys to look at the check boxes for the things that have already been cut?
Oh, no, I did not. Thank you.
Okay.
So now these are all been optimized, and it's making the assumption that you cut it all, right? But what you can do is you can go back in and say, no, I want you to optimize. Well, it's actually just that one assembly. So I want you to optimize. I don't want to cut these, or I've already cut those. This should work such that when you come back, these 3 boards are marked as having been optimized.
Right. They've already
Which
been cut.
actually they are marked. They're just.
But it doesn't keep it.
That's the point.
Yeah,
so the next time you open this project and run the optimizer, it should tell you that these 3 aren't going to be cut right now. And again, it's all right. And that is what I had hoped to accomplish tonight.